Hello, Matthews Gatos here. In this video, I'm going to do two examples of a three-dimensional problem and then get you guys to try some on your own as well. So imagine we have this box and it measures 10 by 12 by 15, and I want to put a rod or maybe like a drumstick in there. I want to know what the longest rod that can be carried in that box is and what does the angle it make with the bottom. So let's look at this in two steps. It is a three-dimensional problem because you have your length and your width and you're adding on an element of height. That's what makes it a 3D problem. So we need to first find out the length D, which is the hypotenuse of a triangle right here on the bottom. So we're going to start by finding length D. So I'm going to write out my Pythagorean theorem, a squared plus b squared equals c squared. So it doesn't matter which one you call a and b. You're going to square them and add them together. And it's equal to c squared. I wrote it as d squared because that's what it's labeled on the bottom. If I just move this to the side, you can see it's a d. Okay, so just to be clear, it's a squared plus b squared equals to c squared, but I'm calling c squared d because that's the way they drew the triangle. So putting this into your calculator, I see that a squared plus b squared equals 369. So that means that d squared equals 369, and of course d equals the square root. So d is equal to the square root, which is 19.2 centimeters. Now that I know that this is 19.2 centimeters, I can find the hypotenuse of the other triangle. So it's going to be with the rod, the height, and again, the hypotenuse is now going to be the new base. So this is the new triangle that I'm dealing with now. Okay, so I know that that one's 19.2, and I'm going to try and find the side length L here, and then this angle here. So let's start with L first. Again, this is Pythagorean theorem. So I have a squared plus b squared equals c squared. So 19.2 squared plus b squared equals, now they call that length there L squared, so I'll do it just like that. So here I put it into my calculator, so 19.2 squared plus 10 squared, this is what L squared is. So L is equal to the square root of that. So L is equal to 21.7. So now all I have to do is figure out what the angle is, and it's an angle of elevation. We always use tangent for that, which is opposite over adjacent. So tangent of my angle is equal to opposite over adjacent 19.2. Now I don't know my angle, so I need to use second tan to go back to find out what my angle is. So second tan of 10 divided by 19.2. So I put that onto my calculator here, and you can see we usually do it to the nearest degree. My angle is 28 degrees. Okay, let's try this one here. So build your skills, page 222, number 8A, and we'll also do B. B is the angle of elevation at the bottom. So we have the straight line distance, and B is the angle of elevation. So I'm going to borrow from the rectangular prism idea that I just did and draw what it might look like. So I have an airplane that is flying 100 kilometers north and 185 kilometers west of an airport, and it's flying at a height of 7 kilometers. So since I put the element of height on there, I know that this is a three-dimensional problem. So here's what I drew as my diagram here. So we have the airport, which is north and west, and then I'm flying at a height of 7. I want to know the distance between the airplane and the airport, and I have to do this in two different stages. So the first thing I'm going to do is find the hypotenuse of the bottom triangle. So to do that, I'm going to do my Pythagorean theorem. A squared plus b squared equals c squared. So I'm going to have 185 squared plus 100 squared equals c squared. Okay, so for the bottom C there, this is what c squared is equal to. So c is the square root of that, which is 210.3. So 210.3 kilometers. That's going to give me this. Now I'm going to use that to find my other triangle. So it's going to have a height. I'm going to use the base here of C and connect the two distances, and that's going to be my new hypotenuse. So in my next triangle, I'm going to do this. So I have the 210.3 that I just figured out with the height of 7, and I'm going to find the hypotenuse here, and then again the angle of elevation. So again, Pythagorean theorem is a squared plus b squared equals c squared. So 7 squared plus 210.3 squared will equal to my c squared. So putting that into my calculator to get what the top c is, this is c squared. And to figure out what c is, I take the square root. So the distance from the airplane to the airport, so from the plane to the airport, it's now going to have a distance of 210.4 kilometers. And then the angle of elevation, we always use tangent for that, so opposite over adjacent. So tan of my angle is opposite 7 over adjacent 210.3. I don't know the angle. I want to go backwards to find it, so I do second tan to do that. So tan inverse of 7 over 210.3, and I get 1.9 or 2 degrees would be the angle of elevation. So I hope those two questions helped you. What I'd like you guys to do tied to that is work on these following questions, which are also the 3D type questions. And the last two that I did will help you on that. So I hope that video helped, and I'll see you soon.